All right, so this comes right out of the predicting products combustion notes. These are the two examples. We're going to completely go over this one together, and then I'll tell you when you can work on that one and put up the answer afterwards for the you try. So combustion is the only reaction where the products are identical. Normally we have a pattern for how to predict the products, but for combustion, it's always the same two products, carbon dioxide and water. And that's helpful for us for actually using combustion because neither of those is very dangerous other than the fact that they're greenhouse gases. So with these, our general format, you're going to have a hydrocarbon. The numbers can change, but it doesn't matter. It's still just going to be, when you see these, something with carbon and hydrogen and possibly oxygen plus O2, because oxygen's a diatomic molecule. On the right side, you're always going to start by putting the two products, CO2 and H2O. Now, these ones are probably the easiest to predict the products, but they can be the hardest to balance. So it's driving me crazy. I couldn't figure out how to make the numbers small in our examples. Good. I'm going to draw out the rest. So the first example is what you would see. You get to see the left side of the arrow, and then you predict. So right off the bat, we know it's CO2 and H2O because that's what the products always are. And I'm going to put a blank here to leave space for balancing. And it's totally fine to put H2O first and then CO2. Doesn't matter the order. I always put CO2 first because carbon comes first in the hydrocarbon. When we balance these, as I said, these can be harder to balance. Always start with a carbon and hydrogen because they're in compounds, and save oxygen for the end because it's by itself on the left side. So that one, we don't have to worry about balancing anything else. And oxygen is also in both the products, so that makes it a little tricky. With these ones, work in pencil or something you can erase because they can change. So I'll write out our little tally here. I'm gonna need a second column. I'll squiggle. Okay, so starting off, we have 8 carbons, 10 hydrogens, and 2 oxygens on the reactant side, 1 carbon, 2 hydrogens, and 3 oxygens in total on the right side. As I said, we're gonna do oxygen last. So I'll start with carbon because that's the first one we see on the left side. Quick note, sometimes we have to go back and fix these. This is gonna be one of them. If your hydrogen is divisible by 4, your oxygens will work out first pass. If not, you're going to be changing your numbers. You're going to have to double it. All right, so, but we're going to start off like we normally would. So carbon is 8. We want 8 on the right side, so we're going to put 8 on the line. Update that one to 8. I'm actually not even going to update my oxygens until the end. I'm going to balance carbon and hydrogen first, and then I'll count the oxygens in total because they'll change both times. Hydrogen is 10. We need 10 on the right side because there's a 2 in the formula. That means we put a 5 on that line, and that makes this one 10. And now we can add up the oxygens. So 8 times 2 is 16 plus 5. 16 plus 5 is 21. All right, so now this is where I did say we're going to have to go back and change them. So 21 is an odd number, and over on the reactant side, we have an O2, so it has to be divisible by 2. We can't put fractions or decimals on these lines. They have to be whole numbers. So when we run into an odd number of oxygens, what we're going to do is we can go back and double everything. So if we put a 2 on this first line, carbon can change to 16, hydrogen to 20, oxygen doesn't have to change. This instead becomes 16. That'll make 16 carbons. This becomes 10. It's the 20 hydrogens. And this becomes 42. Now that we have an even number, we can divide that by 2 and put that on the line. That's 21. So I went a little quick going through the balancing, but these ones are tricky. Know that these ones are some of the hardest to balance. Anytime you end up with an odd number of oxygens, you can go back and double this and kind of start again when you're doing them. Okay, so this is our example problem. If you want to do the you try on your own, you can pause the video right now. Okay, I'm going to put the you try answer up on the board or on our whiteboard here. So we see a hydrocarbon and oxygen. We know it's a combustion right off the bat. CO2 plus H2O. This one I'm not going to do our tally. I'm just going to put the numbers. Carbon, 1 and 1. That one's good. Hydrogen, 4. We need 4 here. That'll be 2. We can finish up with the oxygens. We have 2 from CO2, 2 from H2O. That's 4 in total. To get 4 on this side, we just need a 2 on that line. Look at that one. Way easier to balance. So some of them are easier. Some of them, like the first one, are harder. Anticipate seeing a mixture of both. All right, so that's combustion.